The following series is absolutely convergent, conditionally convergent, or divergent. Here we got an alternating series because of this negative 1 raised to n minus 1. We are getting positive, negative terms. Now we can try to see if this series converges by the alternating series test. Alternating series test. That is, we denote this by Bn. The whole term, including negative 1 raised to n minus 1, these are Ans, but this one alone are Bns. For the alternating series test, we need two things to get satisfied. First, those Bns should be decreasing. The next term should be smaller than the previous. And not only Bns should decrease, they should decrease to 0. When we take this limit, it has to go to 0. Looking at this 2n plus 5 over 3n plus 1, the bottom grows faster because 3 times that. That first condition is kind of satisfied. We can see that's satisfied. But this one is not gonna go to 0. When n goes to infinity, we got 2n, 3n. These are the leading terms, so it's gonna go to 2/3. So this condition is not satisfied. So we cannot use the alternating series test to show this series converges. But look at one thing, okay? These Bns are not going to 0, they are going to 2/3. That means with negative 1 raised to n minus 1, the whole thing is not going to go to 0. That is the necessary condition for any series to be convergent. So let me do this then. The easiest thing, because this is not going to 0, the whole thing is An, and these are Bns. Okay, that's how we denote in an alternating series. Limit of Bn when n goes to infinity is limit of, I'm using the test for divergence. Okay, let me test for divergence, which is if the limit of An when n going to infinity is not equal to 0, then the series diverges. This is sometimes called nth test for nth term series test. That is n going to infinity of Bn means 2n plus 5 over 3n plus 1. Now this is limit at infinity. 2n is the leading term on the top, 3n is the leading term on the bottom. So when n is really big, this is going to go to 2/3. Okay, which is not 0, but that's just for Bn. Then how about whole An? That is needed with negative 1 raised to n minus 1. When n goes to infinity, this is not going to be 0. It should be negative, positive of 2/3. That means this dne, the limit does not exist. Or we can say limit of An when n going to infinity is not equal to 0. This is good enough. In fact, the limit does not exist because we are going to get negative, positive of 2/3. Then by the test for divergence, the given series diverges, or the series is divergent.